Hey there! Thanks for tuning into my video on how we're going to find the nth term of a geometric sequence. Let's start off this video by reviewing what a sequence is. If you recall, a sequence is just an ordered list of numbers. Each number in the sequence is called a term, and each term has a specific position in the sequence. Here's a sequence, 5, 10, 15, 20, and so on, and if you recall, a sub 1 would be in the first term, a sub 3 the third term. We've already learned about arithmetic sequences. What an arithmetic sequence is it's an ordered list of numbers in which the terms have a common difference. In this sequence, you can see the common difference is 2. These terms are increasing by 2. If these were to go down by 2, we would say the common difference is negative 2. Today what we want to talk about is what is a geometric sequence. A geometric sequence is clearly different than an arithmetic sequence. The definition of a geometric sequence is when the ratio between consecutive terms is the same. The ratio is called the common ratio, and each term is found by multiplying the previous term by the common ratio. Here are two examples. Both of these are examples of geometric sequences. If I look in example 1, I can see it's not arithmetic because to get from 1 to 3, if I was adding, I would have added 2. And from 3 to 9, I would have added 6. That clearly shows that because those sums aren't the same, that it's not arithmetic. This one is geometric. If I look, in each term I'm multiplying by 3. 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, and so on. So for example 1, that geometric sequence, we would say the common ratio is 3, r equals 3. The second example, you might say, hey, I noticed the pattern that's going on here. To get from 8 to 4, I divided by 2. To get from 4 to 2, I divided by 2. 2 to 1, divided by 2. And 1 to 1/2, divided by 2, and so on. While you'd be correct, we want to think about geometric sequences always in terms of multiplication, and that's why I underline multiplying there. Well, think about it. If we're dividing by a 2, that would be the same as multiplying by the reciprocal or multiplying by a half. So here we would say the common ratio is 1/2. We always think about geometric sequences in terms of multiplying, never dividing. If you're having a problem finding a common ratio of a sequence, you can always take any term and divide it by the previous term. 2 divided by 4 would be a half. I could have also taken these two terms, 4 and 8. If I take any term and divide it by the previous term, it gives me the common ratio. 4 divided by 8 was also a half. And you could see in example 1 that also works. 27 divided by 9, that's 3. That will always find you the common ratio. Let's look at some sequences and you tell me, are these geometric or not? Let's take a look at the first one. Is the first one geometric? The answer is no. This is an arithmetic sequence. I can see here that these ones here are going down by 2. We would say here the common difference is negative 2. Let's take a look at the second sequence. Is this one geometric? The answer here is yes. If I look at these, the terms are being multiplied by 2. So here for the second sequence, we would say that it has a common ratio of 2, meaning that it's geometric. And let's take a look at the last one. Is this one geometric? The answer here is no. This one looks like it's arithmetic. I'm adding 5, adding 5, adding 5, adding 5, and so on. So this here would be an arithmetic sequence. I can tell because it has a common difference of 5. Let's see if you can try some of these on your own. In problem number 1, I want you to find the 10th term of that following sequence. Go ahead and give that a try. Okay, let's try a difficult one. In number 2, I want you to find the 15th term in this following sequence. Now I'm sure at this point what you've been doing is just kind of continually multiplying the common ratio to find the terms in the sequence. But of course, let's look on the next slide at the patterns that would help us develop a formula. If I want to find the 15th term in that sequence you did, think about how these terms relate to the bigger picture. The first term I started with, we know we can symbolize by a subscript 1, meaning the first term. Well, think about how I got from the first term to 6. What I did was I multiplied by 3, which in this case is the common ratio. So to get to the second term, what I did was I took a1 and multiplied by the common ratio. Think how I got from 6 to 18. From here, I multiplied 6 by 3, or really the common ratio. So I took this term, a1 times r, and I multiplied it by r. Well, if I multiply r by r, what I'm going to get is r squared. Now think about how I got to 54. I multiplied 18 by 3, or really I multiplied this expression by 3, which was the common ratio. R squared times r becomes r cubed. You could probably look at the pattern and see what this expression would be represented by. Well, here I had a1 times really r to the 0, a1 times r to the first, a1 times r squared, a1 times r cubed. If you guessed a1 times r to the fourth, you'd be correct. So the fifth term had the common ratio to the fourth, the fourth term had the common ratio to the third, and the third term had the common ratio squared. Well, you may have guessed it, this formula here finds the nth term of a geometric sequence. Any term is represented by the first term times the common ratio to the n minus 1. So let's solve this problem using the formula. All I have to do here is identify the first term and the common ratio. Here I can see the first term is 2, and to get to each consecutive term, I'm multiplying by 3. So the first term is 2, the common ratio is 3. I know this is a geometric sequence, so I'll use my formula. For a1, I'll plug in 2. For common ratio, I'll plug in 3. What's nice about geometric sequences is, unlike the arithmetic ones, there's nothing to simplify. This here is the formula to find any term. Notice I didn't have to distribute, I didn't have to combine like terms, I just have the formula. Now when I want to find the 15th term, I'll plug in 15 here, and I'll also plug in 15 here just for the notation part. So I plug in, this says the 15th term is 2 times 3 to the 15 minus 1. I like to simplify this piece on my own and then just throw it in the calculator. 15 minus 1 is 14, and when I calculate this in the calculator, the 15th term is 9,565,938. That got very large very quickly. What I want you guys to try to do on the next one is, even though you may be able to count by doing repeated multiplication what the term might be, practice using this formula here. That's really important. So in number 3, what I want you to do is first write a rule for the nth term of the sequence. Then after you do that, use that rule to find the 7th term. Do not just do continued multiplication. Gain practice using the formula here. So give that a shot. Okay, let's see how you did. Here I should realize that the first term is 13, and I have a common ratio here of 2. Each term is being multiplied by 2. To find the formula, I'll just use this rule here for geometric sequences. Plug in the first term is 13, the common ratio is 2, and we know with geometric sequences, we're done. That's the rule. No need to distribute or combine like terms like we did for an arithmetic sequence. To find the 7th term, I'm going to plug in 7. I'll plug in 7 here to indicate the 7th term, and here to actually compute what the 7th term is. I like to do this piece in my head. 7 minus 1 is 6. And when I find the 7th term here, I can see it's 832. Let's try one more before we get you out of here. In the 4th one, write a rule for the nth term of the sequence. Then use that rule to find the 7th term. Again, it's important to get in the habit of using the rules and gain practice, not just doing repeated multiplication. So give that a try. Let's see if you got it. Here I can see the first term is 1, and the common ratio here is a little bit difficult. To get from 1 to -5, I multiplied by -5. To get from -5 to 25, I multiplied by -5, so the common ratio here is -5. Because it's a geometric sequence, I can use this formula. For a sub 1, I'll plug in 1. For the common ratio, I'll plug in -5. Here is my rule. Now to find the 7th term, I'm just going to plug in 7. Here this says the 7th term equals 1 times a base of -5 to the 7 minus 1, or 6th power. When I compute that, I should see that the 7th term is 15,625. I hope you learned a lot about geometric sequences from watching this video. Thanks so much for tuning in.